So this is the last part of the lesson. A theorem they found. If k is positive rational number, a constant number over x power of n, what they found out, and you are doing a substitution but to an x approaches infinity. They found out as simple as this that the answer is 0. Example, as simple as this, if there's a 3 over x power of 4 or 1 or whatever the number is, and the power x is down, as simple as this, they found that the answer is 0. Why this? Now, I want you to keep this note in mind. Divide by the leading coefficient term of the denominator. What does that mean? And this part also to find the horizontal asymptotes. Right. An example. What about a question if it's given? What they found out, as simple as that, divide by x squared. Why x squared? Where's the leading term in the denominator? It's a 3x squared. That's the leading term. So I will take x squared. And as you can see, I will divide each term by x squared. Look at the green over here. Next step, we'll simplify. This one will be a 2. Simplification of this one will be a 3. This one will be a 5 over x squared. Now, when I find the limits, what did we said from the beginning? If there's a constant number over x, the answer is 0. So this is 0, as you can see. This one is 0, this one is 0. So what's left? 2 minus 0 over 3 plus 0 plus 0. So the answer is 2 over 3. And horizontal asymptote line, we can use what? Limit as x approaches positive infinity or negative infinity. It's up to you, f of x over g of x. If the question said find the vertical asymptotes and the horizontal asymptotes, what we will do, let me start with the easiest one. This is the function given to you, and the question is asking you to find the vertical asymptote line. What you will do in this case? As simple as that. Remember what we said? We will take denominator and make it equals to 0 and solve it. And I got the plus and minus 4. So what about finding horizontal asymptote line? Do you remember when we used to memorize power up, power down? Now, instead of that, there's an easier way, which means using a limit. So I will say limit as x approaches infinity for 1 over x squared minus 16. Do you remember what we said in the previous video? We said we will divide by the leading coefficient in the denominator, leading term in the denominator, which is x squared. So I will divide each term by x squared. Now, when I simplify this one, it will be 1 over x squared. When I simplify x squared over x squared will be what? Will be a 1. When I simplify 16 over x squared, cannot be simplified, so I will leave it as it is. The limit of this is what? It's a 0. Limit of this is what? It's a 0 also. Once you see an x in denominator and there's a constant up, directly it's a 0. So 0 over 1, so the horizontal line is y is equal to 0. Okay. What about part B? X cubic minus x over 2x squared minus 4. Now to find vertical asymptote line, take the denominator, make it equals to 0, solve it, and find the answer. And as you can see, how can I find the answer? It's an equation and taking the square root. What about the horizontal asymptote line? Like we said, we will make it a limit, does not matter. I told you positive or negative infinity, but in my case, I will choose the positive each time because it's easier to deal with. Now, I will divide all of the terms by x cubic or by x squared. Akid by x squared. We said from the denominator, we won't look at the numerator. So dividing that, x cubic over x squared, x over x squared, 2x squared over x squared, negative 4 over x squared. Simplification, look at the simplification, what happens. I think it's easy. Next step, now finding in limits. When I substitute over here, infinity. This is 0, like we said. This one is 2, and this one is 0. Which means infinity over 2, which is infinity. So what does that mean? No horizontal asymptote line.